Hi guys, so we are going to solve these problems about the photoelectric effect. Let's start with a photosurface has a work function of 1.50 eV. Determine the critical frequency. Light of frequency 6.10 times 10 to the 14 hertz falls on the surface. Calculate the energy and speed of the electron. So you notice that there is the photosurface that has a work function of 1.50 eV. So remember that with the conversion before, we understand that 1 eV is equal to 1.6 times 10 to the negative 19 joules. You're determining for the frequency, so E is equal to HF, where H is the Planck's constant, F is the frequency, and E will be the work function here. So frequency will be equal to E over H. Your E, so that means that F is equal to 1.50 times 1.6 times 10 to the negative 19 all over the Planck's constant, which is 6.63 times 10 to the negative 34. So the frequency of this one will be 3.62 times 10 to the 14th hertz. Then you're done with that. Now, for letter B, light of frequency 6.10 times 10 to the 14 falls on the surface. Notice, class, that this 3.62 times 10 to the 14th hertz is the threshold of frequency. That means that any frequency that is being received by the photosurface that is higher onto that can lead to an ejection of the electrons. So with this, we can determine the energy that we will be having. So we can have E is equal to HF minus HF times the critical frequency. So we can have also H times F minus critical frequency. So yes, we can have 6.63 times 10 to the negative 34 times 6.10, which is this one, which is the first one, 6.10 minus 3.62 times 10 to the 14th. You notice, class, that this is equal to 1.64 times 10 to the negative 19 joules. This is the kinetic energy of the electrons. But then again, there is a question we're in. It's looking for also the speed. Knowing the formula of kinetic energy is equal to 1/2 mv squared. We already have the kinetic energy and we already have the mass of the electron, which is a constant, which is 9.11 times 10 to the negative 31. So we can have V is equal to the square root of 2ke over m. Substituting all the given, we can have velocity, which is equal to 6.0 times 10 to the 5th meters per second. That means that the speed of the electrons being ejected is 6 times 10 to the 5th meters per second. This is for number 1.